Now let us begin with electrostatics. In electrostatics, the first thing that we know that when charges are at rest, the charges are at rest. Let us consider, first let us ask the question, what do you mean by a charge? So what is a charge? Can you define what is a charge?
So it's either
Yes, excess of, if you consider an element will have equal number of positive charges and an equal number of negative charges. But in certain elements, by some mechanisms, if you remove the negative charges from here, which means you are left out with more positive charge, and as a result of it, you say this is positively charged. Okay, I have described the phenomena here as how do you make something a charged particle. But the question here is, what do you understand by charge? Okay, now let me ask you one more question. Instead of charges, what do you understand by mass? When I ask you what do you mean by mass, do you have any answer? Yeah.
It's a measure of the inertia of a body.
It's a measure of the inertia of the body, and you can say that this is a fundamental entity, right? You can say that the mass is a fundamental entity. So in a similar way, can we also define charge also as a fundamental entity?
Yes.
That means charge cannot be described in terms of any other entities. So mass or charge or even time, okay, then length. So like this, there are 7 different quantities and all these are fundamental entities. Okay, and charge can be expressed in terms of current and time, okay, which you get it as current multiplied by time. Anyway, that comes later on because of owing to the units and dimensions that you have studied in your first year. So currently we can say the charge is also a fundamental entity. Okay, so a charge is a fundamental entity, and there are 2 types of charges. One is a positive charge, the other one is a negative charge. Now, how do I create charges? How to create charges? What method? What method can I use to create charges?
So you can either like use addition or removal of protons.
Sorry? How do I create charges?
Addition of electrons or protons or something.
Addition of electrons or protons makes an object to be a charged one. Okay, can we add electrons? Can I take one electron? Is it possible to take an electron?
You can take an
Yeah?
electron. You
can take an electron?
Yes.
Okay, so I can collect electrons somewhere? Can I collect electrons? I can say, okay, I have taken 1 electron, 5 electrons, 100 electrons, and so on. Is it possible?
You can't take it like that, but you can isolate a single electron.
Right, so you cannot take it across. Okay, so then how do I create the charges then? Because the moment I say creating charges, which means it should be either positive charges or it should be negative charges, which again tells me that when I say I have created only positive charges, which tells me it is devoid. If I say it's a positive charge, positively charged object, which means it has less number of electrons. It has less number of electrons. Am I right?
Yes.
Okay, so therefore somewhere we have to do some work in order to remove the electrons from an atom, so that it is being ripped off from the atom, so that the atom behaves like a positively charged particle. That's what we have to do it. So basically, let us see the mechanisms, and basically we will see about what are the different methods of creating charged objects. The first method is known as friction. We can use friction. We can rub against 2 substances in order to remove the charges from one substance to another. This is known as by friction method. The second one is by conduction. Conduction method. Conduction is what you suggested, saying that you add some electrons to an object and automatically the object becomes conducting or it becomes charged. Right? So therefore, that's what is called conduction method. The last one is about method of induction. Okay, these are 3 different methods that we have. All the 3 methods we need to know. Okay, now let us start with the first method. The first method of charging an object is by friction. Now let us consider 2 objects. One of them is a glass rod. One of them is a glass rod. The other one is silk. silk.
Yeah.
Now what I do is I rub one against the other. When I rub one against the other, now before rubbing, okay, let us consider there are 30 protons, and since protons should be electrons equal to electrons, there should be 30 electrons over here. In the silk, let us say, for example, this will have, let us say, 20 protons and 20 electrons. These are initial quantities. Now, when I rub against each other, then what can happen is the glass rod can become positively charged, which means this will have 30 protons and this will lose 5 electrons, for example. So therefore, this becomes 25 electrons. And the silk cloth will become 20 protons and it will have 20, and this 5 electrons has jumped over here. So this becomes 25 electrons. So this is positively, sorry. So this is neutral. This is neutral. Both of them are neutral here and here. This becomes more positive and this becomes more negative over here. So thus you see that this object has been said to lose some electrons, negative charges. It has become a positively charged object, and this is seen to be gained electrons. So you say it has become negatively charged object. Thus, we are able to create, okay, two charged objects just by rubbing with each other. But the only thing that you need to look at is that when we start rubbing with each other, one of them should be able to donate an electron. The other should be having a capacity to receive an electron. And only if these two are seen, yes, the total number of electrons will be the same. Okay, after the number of charges, see, this together will be a system. The charges seem to be conserved completely. The charges get distributed. The charges get distributed. And that is when the friction comes into play. And as a result of the friction, you can see the charges gets transferred from one object to the other object, thereby making one of them to be a positive charge, the other one to be a negatively charged. Is this clear?
Yes, sir.
Okay. So now that we have seen how to charge an object making use of friction, now let us look at the next one. Okay, in the friction, I have one more question here. Now let us say, for example, if this is instead of a glass rod, if this was let us say a steel rod, and the silk cloth that I have used, instead of a silk cloth, I have used an aluminium paper, aluminium foil. Okay. Now what can happen when I rub a steel rod with an aluminium foil? What can happen? Will the charges get transferred, or what can happen? Yeah.
I don't think so. I mean, it depends, right? I don't. Both of them have a capacity to lose electrons.
Correct. As a result of it, who will lose electrons? Will anybody lose electrons? Will steel lose electrons? Aluminum gain electrons? What can happen?
I don't think anything will happen, right? Because both are
mercury. Anything will not happen, right? So therefore, if charges to be get transferred, we need that these two substances should be insulators. Okay, these two substances should be insulators. If they are not insulators and if they are just pure metals, then definitely, okay, both of them are of a similar type. So nobody is an electron donator, nobody is an electron recipient. And as a result of this, you can see that the two objects will not get charged. Okay, now let us move on to the next one. The second one, as I suggested, is by the method of conduction. Conduction method tells us that, okay, it's very simple, it's self-explanatory, which tells us that you have an object, let us say this is again an insulator I'm going to consider, and then I take another object which is positively charged, like this, and I'm going to touch this one. When I'm going to touch this, then this becomes positively charged. What happens to this object?
Which one?
The first one. The first one is a positively charged object. Then the second one is a neutral object. When I touch with each other, okay, then when I'm keeping this in contact, then as I observe, this will become positively charged. What happens to the first object? Will it lose all the positive charges to it?
It won't, right? It will always, it needs to be in equilibrium, right?
Yeah, so which means, let us say, for example, if there are 30 charges here, and here this has no charges over here, which means what will happen now? What will be the charge deposited here?
So it'll be
After
15
touching?
coulomb.
Yeah, this will be 15Q and this will also be 15Q here. The charges will be equally distributed between the two objects. So that is what you can expect. Okay, so now we have seen what happens in case of conduction. Okay, so now what I want to do is, let us say for example, if this one is a metallic object, instead of an insulator, I took an insulator, I have written it like this. Now what will happen? If I take these charges and transfer it to here, what can happen? Instead of this being an insulator, earlier it was an insulator, now it's a metal. Now what will happen?
It has a gain to lose, it has a tendency to lose, right? So no transfer.
No transfer will occur, so charges will not get transferred here.
I don't think no transfer will occur, right? It's like
when you touch this one here, the charges that are present here will again come back to this, but the only difference is that the charges will not get lined only at this point. It will get throughout distributed. You get distributed throughout. Because the advantage is that the charges are now free to move in the metal. Right? On the other hand, in case of an insulator, when you drop or when you touch the charges over here, it won't stop. It has to stop there itself. It offers the insulator or a plastic will offer higher resistance. So it cannot move further. Correct?
yes, sir.
Okay, so but while a metal is not like that, it offers very least resistance or zero resistance. As a result of it, the charges that you have put over here will get equally distributed at all the sides over here. Okay, now let us consider, yeah, we have seen metal, we have seen conduction, we have seen what happens in case of these two, right? Now let us look at the third method of charging an object, which is my induction. In induction method, let us say I have a insulator which is having positively charged object here, and I have a neutral object here. This is neutral. Now what I do is I bring this one closer to each other. I bring it closer to each other, but I don't touch it. As a result of this, when I bring it nearby here, the positive charges present here will now try to induce negative charges over here. Which means this object already had positive charge and negative charge together. The negative charges are being brought nearby here, and the positive charges are made to move farther away from here. Okay, so this is what you call as induction. You are not going to touch it at any cost. Okay, you're just going to bring it nearby. As a result of it, there is a charge separation that takes place. And when there is a charge separation takes place, the negative charges assemble here, positive charges assemble here, and this is what you call as charge separation. Okay, so charge separation takes place, or you can say that this edge is negatively charged, this edge is positively charged. And it's supposed by some mechanism, if you now remove this positively charges present in the material by connecting this to a ground. What do you mean by ground? You take a wire, connect it to the ground, only this edge, and all the positive charges present here will now try to move here because it has to go from a higher potential to a lower potential. It moves over here, and then you remove this. And after that, okay, when you remove this object also, the negative charges will not get combined with the positive charges because positive charges are lesser. So more amount of negative charges here. So this object becomes a negatively charged object. Is this clear?
Yes, sir.
Okay, so by induction method also you can arrive at a charge separation. Sorry, you can arrive at a charging an object. Okay. Now, so far we have seen what you mean by charge, how you charge an object, and how you charge an object. That's what we have seen. The next one is how do you detect charges? How do you detect charges? When I ask you to detect a mass, you can easily detect a mass. You can say we have a weighing machine, we can put it across. But how do you detect a charge? What method would you like to use to detect a charge? Okay. The first thing is, now we have seen about a charge. What are the properties of charges? The simplest properties of charges. What is the property?
Simple. It's either excess of electrons or lesser electrons, right?
Yeah, that is the way how you define a charge. But the simplest property is that when you have two positive charges, what happens? They will repel. When you have a positive charge and a negative charge, what will happen?
When you it'll like attract it.
It will attract. When you have a negative charge and a positive charge, then also there will be an attraction. When you have a negative charge and a negative charge, then what can happen?
So repulsion.
They will also repel, right? So that's what we say, like charges repel each other and unlike charges attract each other, correct? So this is what is happening. In other words, you can detect the charges based on this principle. So which means that you take one object, okay, charge it with some mechanism. Okay, we do not know what is the charge here. And then you take another object, charge it over here, you bring these two objects, and whether you see that whether these two objects are being pushed away or pulled together, then definitely both the objects are being charged. If they are not happening, nothing is happening over here, you can say that the object is neither being charged. Correct?
Yes.
Right. So now we will do this with the help of an equipment or an instrument known as electroscope. An electroscope is something like it's a glass jar wherein you have an ebonite rod which goes inside it like this, and then there's a cork which tightly fits it so that the air does not enter through it. The ebonite rod at one end will be having a small hook-like structure, and to this hook you have two gold leaves. Okay, the real gold leaves which are very much thin, okay, of the order of 1 milligram or something. And then to the top of the bottle here, you have a small knob here. So this is made out of graphite. This is made out of graphite again. And then what you do is, initially the two leaves are seen to be bent like this. They appear to be overlapped with each other. Now what you do, you take a balloon. Okay, take a balloon, rub it on your hair and bring it nearby to it. Or maybe you can touch it also. Now when you touch it across, so what can happen is the hair, the balloon becomes negatively charged and the hair becomes positively charged. And as a result of it, this is negatively charged over here. This negatively charged, when you touch it across here, the charges will now try to flow like this because this is a metallic conductor. So it goes like this. It gets deposited both on these leaves. So the first leaf here will also become negatively charged. The second leaf also becomes negatively charged. And thus, the leaves which were initially overlapping with each other like this will now try to diverge. Because this is also negatively charged. This is also like to negatively charged. So it will start to diverge. Now, suppose if I rub it too much time, many times, okay, something like 10 times, 15 times, more amount of charge is getting deposited, and I put it over here, you can observe through the glass jar that the leaves will immediately diverge like this. But if little amount of charge is being present, then the leaves diverge only for a smaller angle. The amount of divergence tells us to what charge was the balloon being charged across. Is this clear?
Yes.
So this is what you call it as an electroscope. Electroscope, this is a device to detect charges.